Okay, here we go. See, like these ones when I was getting thrown off and it was like face, like it would say like a literally like a word.
Yeah. Yeah, we're gonna do the same thing there. We're gonna write out all the letters, and that's how I would recommend doing it. So all the letters that come before E, so that's A, B, C, and D, A, B, C, and D, and then we've got F, A, C, and E. So X and Y means it has to be in both. Sometimes it's good to reorder them in alphabetical order.
Okay.
Face becomes A, C, E, F. Um, and then and means both. They have to be in both. So that's A and C, looks like. Or means it could be in one or the other or both. Basically, it's everything that you see. So it's A, it's B, it's C, it's D, it's E, it's F. All right. So the complement of event Y can seem very difficult because all the other letters besides space. But if you read up here, it says the first seven letters of the alphabets. That's A, B, C, D, E, F, G.
Mhm.
Okay, I know my ABCs. The complement of Y is those that are not. It's everything. Like you could start crossing them out. Is another way to do it. Cross out F because F is there. Cross out A. Cross out C. Cross out E. So what's left over is the complement. That's
Yeah.
another way you might consider doing it.
Yeah, I guess that's better. It was a better way to thinking it. Okay.
I know it's a small thing, but you may want to consider using like the capital letters. I guess it didn't matter in that
Oh,
last one,
okay.
but sometimes they're really really finicky about that. All right, let me grab this one. All right, I'm gonna share my screen. Okay, so bag contains 8 marbles numbered 1 through 8, so it might be good to write those out. Okay, A is a number from 2 to 5. So the way I read that is that it includes those edge points, and then an even number is 2, 4, 6, and 8. All right. So now, why don't you tell me the and I think is the easiest. What is the and in this case?
In the end,
What's
I
what's
believe.
in both of these?
So it'd be like two and this two.
You got to go letter by letter,
Oh,
like
and
it's 3 in both, there's 4 in both,
four, two,
or
four. Yeah, I don't.
and that's it. Yeah, 5 is not in
Oh,
both, 6 not in both. So you got it there. Now the or, like what you do is you kind of start with one of them. You pick
mhm.
off like ones that are in the other. So you might start with like 2, 3, 4, and 5. And then you say, okay, well, I've already got a 2, I've already got a 4. Oh, I don't have a 6. Oh, I don't have an 8. So for the or, I like starting with one or the other, and then adding to it. So the complement of A, that's where you go back to like your main set here. And A is 2 to 5, so you start just crossing those out. And you're like, what do I have left over? Well, 1, 6, 7, and 8.
So for like the compliment, we would look at like the first
Yeah,
option, first one.
the like what's called the universal set.
One second, sorry, just taking everything that I was watching how you were doing it. So for this one, I was starting to get some of it. So I was looking for like the keywords, like you were saying, like the
I,
randomly.
I'm not seeing your screen. I'm
Oh,
seeing like
sorry, something else.
well, I'm seeing like half like the top edge of your screen. Retry. There it is. Okay.
Okay, yeah. So for this one, I was starting to get most of it, but I was getting through like I was looking for like the keywords like you were telling me, like the randomly selected and then like putting
Yeah.
it back.
So the keyword that you're looking for here is whether the thing that is in the experiment, whether it removes something. So see how
Mhm.
in the first box it says set aside?
Yes.
When it's set aside, the next one is dependent on the first one.
Okay.
Okay. In the second one with the paperclip, it says thrown away, thrown away.
So that would be
That's like setting aside. So that is
a
dependent.
dependent. Okay,
Yeah.
because it's not put back into it. I
Yeah.
see.
Now in the fourth one, we'll get to the spinner in a moment. The fourth one where it's returned, returned is independent. If you put
Mhm.
it back in the bag or back in that is independent. So take a look at that last one there and see if it's being returned or not. That's kind of your,
Yes, so it's independent because it
it's
got dropped
independent.
into
Yeah.
the box.
And then the spinner, like you're not removing anything. That's kind of weird to even think about that, but it's independent because it's the same um, number of possibilities each time. So the spinner is independent.
Okay. So this would be dependent because the bean got selected and it was
Yeah.
eaten.
Agree.
Okay. Dependent, independent.
Let's put back. Yep. Good.
Mm, would this still be an independent?
Yeah. Dice and spinners are always independent. I don't know that there's a way you can remove something from it.
And then independent because it got returned back into the bin. The family has two children. So this one I am gonna need help with. A family
You're
has two.
you're the medical person. What do you?
A family
Uh,
has two children. I'm
okay.
sorry.
So I think the way to look at it is like, are you returning one of the children back into the? And I would say no. So these are or I'm sorry, these are independent because the chance is the same. I don't know if that's even true though, Matt. I guess I'll go with it's independent.
Okay, children. I would assume children.
I don't know, truthfully, like 'cause
No, no, no. It's okay.
let me check. I have some resources here. Let me check.
Okay.
This is Alex, right? Alex.
I'm trying to look back on some of the.
So like does the I think the question I guess another way to, and this is how I would teach is like does having a boy impact having another boy? And I guess I always thought they were independent, but you should go with your gut. Like don't let me bias you. I really don't know. I mean, it's one question, you can
Yeah.
always redo. but I don't know. I really don't know what to say.
I'm gonna say dependent as well because it says right here, it says like on the background, I'm looking background, it says if you don't replace the first object, then the two subjects are independent events.
Okay.
I'm gonna go with that.
All right.
Okay, we'll just see.
There it is. You got it.
Okay.
Good. Excellent.
Ooh, that was a little stressful. um, okay, let me get back into it.
All right. Let me grab a snip of this and we'll see if I can help to clear it up. A lot of words here this time. A lot of words. We like the ones with numbers. Share screen. All right. Of the people who fished Clearwater Park today, 72 had a fishing license and 8 did not. Of the people who fished at Mountain View Park today, 63 had a license and 27 did not. Suppose that one fisher from each park is chosen at random. What is the probability that the fisher chosen from Clearwater had a license? That's important, had a license, and Mountain View did not. Okay, so had a license from Clearwater, 72 out of 80. Now, where did the 80 come from? It's the 72 plus 8. That's 80. So if you remember, the probability is the ones we want over the total. Is that okay? Clear?
Yeah.
The other one is did not. So it's 27 out of 90. How did I get 90? Those two added together. 63 plus 27 is 90. The both is when you multiply. So they give you a calculator. We
Yeah.
recommend giving this a try to multiply. I'm also going to do it. It says do not round, which suggests that it maybe works out in a way where it's not the worst number imaginable. Yeah.
I got 0.27.
Yes. Correct. All right. Let me grab a snip here. Okay, a student ran out of time in a multiple choice exam and randomly guessed the answers for two problems. Each problem had 5 answers and only one correct answer. What is the probability that she answered neither of the problems correctly? So the probability of being correct on any one question is 1 out of 5.
And
The
it's because we
probability of not correct, what would that be in this case?
not correct, so it would be 2 because of the.
How many out of 5 are not correct?
Well, I'm saying maybe is it because of like the negative that happens that negative sign in front of the A? Does
No,
that?
forget about those. They're just those are the 5 possible answers, but there's only one that's correct. How
Okay,
many are not correct?
so 4 out of 5.
4 out of 5. Okay. And we're guessing on 2 questions. So 4 out of 5 for question 1, because it wants not correct. 4 out of 5 for question 2.
Mm, 0.64.
It is early for me, so let me know if they're not being clear or not coming through clear.
It was good.
I am not seeing your screen currently.
Oh, sorry.
Okay, let me grab a snip of this. Screen. Okay. At a factory that produces pistons for cars, machine one produced 290 satisfactory and 108 unsatisfactory. That's important. Machine two, 246 satisfactory, 164 unsatisfactory. Suppose that one machine from each is chosen at random. And this is where it's key. Machine one is satisfactory. Machine two is unsatisfactory. So if we go back to machine one, there's 292 that are satisfactory out of 292 plus 108. That's this part. And then the unsatisfactory, there's 164 unsatisfactory from machine two, just grabbing that number, over 246 plus 164, like that. Now the nice thing is that these are both out of 400, which makes it a little bit easier to manipulate here. Go ahead and give that a try, please.
So I got 0.2993.
I agree.
Nope, it said it was wrong.
But
Yeah, here, I'll share my screen.
satisfactory. Oh, you know what? The second one does not add up to 400. That's the issue. It's 410. Ah, boy,
And,
they really, they
oh, okay.
really, they really do it to you here. So 0.292, and it worked out so nicely. So the um the bottom, I don't know if you have do you have your calculators? Maybe you're doing
Yeah.
it by hand. Um, it's yeah, if you it's 410 on the bottom of that second one. And yeah, well, that no, just the second one, but it doesn't change the calculation if you the bottoms can be switched, but it's 410 on the one under 164.
Oh, okay. So I'll put that one back to 400.
Yeah, yeah, it's so and it's 0.292.
Mm-hmm. I did it wrong. Sorry. Okay.
Right. Yeah, I guess you're on a step of this. Did that previous one not go incorrectly?
No, I put an extra zero and then it
Oh boy.
doctored it for that.
Okay, that's all right. We'll get these knocked out real quick. Um,
Yeah.
all right, so 57 male students are smokers, 133 are non-smokers. Females, 30 are smokers, and 270 are non-smokers. A female and male student are chosen at random, or the probability that they're both smokers. So the 57 out of 57 plus 133, that's the male smokers. And on the female side, 30 plus 270. So we'll not make the mistake of misadding these because that was really bad. But it
Okay.
looks like this is 30 over 300, 57 over 190, like that. So you can double check by adding these up on the bottom, making sure they are the correct values.
Okay, 1 second. I'm gonna
I get 0.003.
think that's the. I was adding. I'm sorry. I added the first one to the first time, and that's the number I got. I just did it over.
You did get 190.
No, when I added it on the calculator right here, when I did the 157 and then plus 157.33, it gave me the answer 0.03.
Okay, but yeah, you got to multiply by this other one on the
Yeah,
right.
so yeah, that's I did. So 0.03. And you I entered all those zeros in correct.
I think so. Yeah. Um,
But on this calculator, watch, I'll show you what it shows on here.
I didn't see what you did in the previous problem to
Uh-huh.
you're missing a zero
Okay.
in your answer. Could you go back to your calculator? Because I guess I'm not seeing
Yeah. So this is what
on your,
I copied what you did.
oh, I, so sorry, go ahead and hit, maybe I misdoing it. Yeah, hit enter on that. Okay, yeah, 0.03 is correct. Why did mine, oh, because I misread it.
I think it's just a calculator too. It's okay.
No, I misread my answer. Okay, there we go. That should be good.
Go. Mm,
I've got this up now. Spinner is 20 equally sized sections, 2 of which are green, 18 of which are yellow. Then a spinner is spun, and at the same time a fair coin is tossed. What is the probability the spinner lands on green? So how many greens are there? There are 2 out of 20. That's the green. And then coin tosses on tails. That's 1/2.
and then for
Got
the
it.
yellow, would we use the two for it as well?
Yeah, but we're only interested in green
Green.
and then tails. But yeah, yellow would be 18 out of 20 if we cared or if the problems mentioned something about that. So I get 0.05 for this.
For this one, it showed me on the calculator. I'll show my screen again. I did the 2 over 20,
What am I doing wrong here?
and then it showed me 0.1.
Sorry, could you undo that? I didn't see. I was looking at my
Yeah.
own screen. Yeah, but you have to multiply by 1/2 for the
So then it's
for the uh
I see it.
for the tails.
1 half, is that correct?
Okay, there it is. All right, I'm just gonna step away for less than 30 seconds to grab some more coffee, but I'll be right back with you. New question here.
Yes.
Big important word there at the top that says without replacement. That means you're not putting it back. You're taking it out. So, all right. So suppose we want to choose 2 objects without replacement from the 4 objects: pencil, eraser, desk, and chair. So this is a counting problem. So the first
Mhm.
time there are 4 that you can choose. You're only choosing 1, but there's 4 available. Once you pull 1 out, there's only 3 available. Is that clear? Like,
Yeah.
pull 1 out, there's only 3, so that's 12. Now, that's when order matters, okay? If order does not matter, it's called a combination. And I guess probably some reading on this would have been done, but it's 4, choose 2, or choose 2. Could you go to your calculator there? I want to see if you actually have this available to you
Mhm.
on the right. Yeah, so see how you have that NCR there?
It's fine.
Yes.
Uh-huh.
So that's, you can put the 4 in front and then the 2 uh there. So okay. Yeah, good. All right, let me share my screen here. I guess I want to make sure what you had here. All right. So for the first one, okay, it's 4 times 3, which is 12. 4, because there's 4 objects, you take 1 away, there's 3,
Mhm.
that's 12. The second one, when the choice does not matter, so the first one, order matters,
Order that.
okay? For the second one, order does not. So in this case, this is what you're choosing from, and this is how many you're choosing. And maybe make more sense after another problem or two.
Yeah, no, it does. Yeah,
This ends up being 6.
yeah, that's what I got in the calculator. So maybe I can give the next one a try.
Sure. Yeah, if you want to go ahead and share your screen, I'll look at it.
So, so I got 10 and 10.
Okay, but notice there's a difference in the word. One is relevant. One means, the first one means that order
Oh,
matters. The second one, order does not. So I agree with your second one. It's definitely 10. But for the first one, think about how many choices you have for the first one, first letter. How many are you choosing from for the first letter?
so we're choosing 2 from the first letter. So
But how many are you
A,
choosing from? How many are you choosing from? That's
5.
5. Okay. And then you take 1 away, and then there's 4 that you're choosing from. So when order does not matter, it's 5 times 4
Okay.
for the order not mattering. Or for the order mattering, sorry. Order matters.
So it would be 20.
It'd be 20. Yeah.
So okay, so we'll just whenever like when it comes to questions like that, we're only taking away it like 1 time when order does not
Yeah,
matter?
one time. One time.
One
If
time.
order matters, it's you go down by one each time that you're choosing something.
Thank you. I appreciate your patience so much.
Yeah, of course, part of the job.
Yeah, I'm very dyslexic, so like it takes me a while too.
No, you're doing great. Like, this is the Alex is the most challenging of all the systems that I help students with because there's not like if a lot of the other systems just go out to the internet and you find same problems, same numbers. This one's really good.
Yeah,
So
I've
let
been
me
trying. Yeah.
yeah, and it literally comes down to one word sometimes. Uh,
Mhm.
choice matters. That means that order is important.
Isn't yes, and that's where I'm getting real thrown off with the words, like you
Yeah,
said.
choices matter. Um, this is the example I always use. There's a pot of gold on the other side of the door, and you and your friend are there. And the first one through gets the gold. Does order matter?
Yeah.
Yeah, big time, right?
Mhm.
But in another example, it might not matter. So the order, that's what you have to think about. It's not like,
That's
you
it.
know,
That's a good way to think about it.
so it can be good, it can be bad. If choice does not matter, that's when you're using the combinations, the NCR.
And
So, but this time we're choosing three colors. So for the first bucket, there are four colors you can choose from, but then you take one away. Then there are three colors you can choose from. Then you
mhm.
take one away. There are now two colors you can choose from.
And we would tally all those together.
You multiply them all together. Yeah. Called the counting principle. Now, if choice does not matter, it's four, choose three. The first number is always what you're choosing from. Think of it as the like population or like everything. And this is how many you're choosing.
Many. And I got 4 for that.
Yeah.
Let's get right to it. Mhm.
How close are we to meeting your topic goal, or how many do you have left?
I'm here just 14 more.
Just 14. It's like saying there's just 500 miles left to go on our car flight.
I'm sorry.
Okay. It's a long ways. All right. I was hoping we were closer for you to be able to get this done. Suppose we want to choose five objects without replacement from 14 distinct objects. Okay. If the order matters. So I was glossing over this, but these are permutations.
Mhm.
Okay. And so it's 14p5. So when order matters, that's a permutation. I didn't make up the word. That's just what it is. If order does not matter, that's a combination. 14c5. So you've got a calculator there.
Mhm.
You want to do both of these calculations.
So for the first one, I've got a really big number. I got
Yes.
240240.
The permutations will always be larger than the combinations. Well, greater than or equal to. But most of these probably way bigger. So just be careful entering that into the or make sure you get all the digits.
And then for the next one, I got 2002.
Okay. Yeah, it'll be substantially smaller.
242. And it was correct. I'm going to try the next one. You just let me know if it's correct
Yeah,
or.
yep, I'm seeing your screen. So um, the larger number always comes first in like you have there. That's another thing to kind of check yourself if
To remember.
you're unsure that you got it there.
Okay.
Okay, looks good. So keep in mind the first one is not always permutations. Notice the
Always.
top one there's so your answer to this one will be for letter B. What you're doing right now is for letter B because it always is relevant.
Yep, and that's why I messed up. That's why I jumped the gun. I don't read.
That's okay. I mean, you don't, yeah, I mean, it doesn't, the order doesn't matter, but it's something just to think about, when you're doing it on your own.
Yeah, no. It's something I should think about. So 2002 for this one.
Yeah, 14C5. Yep.
And then, and see, that's what I think I do wrong. Like my eyes like skim through it so fast. I'm like, then I miss the step.
Understood.
Does this look okay?
602. Yeah.
I'm gonna hit check.
All right, let me grab a snip of this that way. It probably is just more, a lot of like extra information. But all right, share screen. Okay, here we go. All right, 219 adults selected. They're classified according to voter registrations. They're just trying to explain like what's in the table. So, uh, what is the relative frequency of adults in the sample who prefer to obtain their information through newspapers? Okay, so we need the total newspapers.
So that would be 49.
Yeah, 49. And so we also need like the total of all of them.
That's 26.
Well, actually, they give it to you. It's 219. I was like, why
Oh,
wouldn't they give it to you? It does hit around your answer to two decimal places.
yes.
So,
So at 0.2237.
point two, so two decimal places, 0.22.
What is really simple to understand, so I could try the next one maybe.
Yeah, let me look at it first before male biology majors. Okay, yeah, this one is something yeah, this one's okay. Why don't you try this one on your own?
Okay. 0.29.
Sorry, could you hit the undo button?
Yeah.
Okay, so male biology is just the 48 males.
So yeah. So I was like, I got a little iffy right there. So just read it
Yeah,
carefully, I guess.
so there you go.
So 0.14. But it's zero. But I would have to. I don't have to round it up, right? Because the 8 is bigger than the
This
4.
is 0.15, yeah.
Yeah. So that's what I'm saying. So the 8's big. Yeah. I would have to round it up.
Okay, so let's read the last part. What is the relative frequency of people in the sample whose place of residence is suburban? So how many suburbans are there?
So we would add them all together throughout the line, right? 124.
So it's 124 out of, and now we need the total, which is 365.
To 0.34.
Yeah. All right, so new question here. Okay, let me grab a snip. I can clear my screen. All right. Oh, sorry, that's not quite there. Okay. Um, big cooler. There's 7 sodas, 7 bottles, 9 cans, 16 bottles of juice, 9 cans of juice. Shonda came in from playing outside, ran from the cooler. It's in a can. Okay, can or soda. So like they're not organizing the data. I mean, you could make a table if you wanted that. And actually, probably would help you quite a bit.
Table.
There is soda, a bottle, can, and then juice, bottle, can. So there's 7 bottles of soda, 9 cans, 16 bottles of juice, and nine cans. So this time we want to know whether choose the drink she chooses in a can or soda. So here are the cans. The cans are here,
9.
and the sodas are here. Okay. Now, do you see that there's like an overlap?
Yes.
So you don't want to double count. So it ends up being 7 plus 9 uh, plus 9.
So 25.
It's 25 over the total, which is 41.
So I got 0.609.
A nearest hundredth. All right, so 0.61. Yep, good.
Thank you so much for explaining that, so I know how to
Of
move
course,
on
yeah.
to
I do think the table's a little extra effort, but it's worth
the good
doing.
breakdown. I appreciate it. Are we gonna stop here? Because I know it's like a minute
No,
before.
let's get another one or two in, see if we can finish
Okay.
up a couple more here. All right, so same thing here. I think we should try to make a table out of this. I'll grab a snip here. All right, share screen. All right, so we have black shirts, black sweaters, and gray sweaters, but no gray shirts. So it can be a little bit hard to figure out like what are they doing here, but it looks like there are shirts and then sweaters. So black shirts and black sweaters, 6 gray sweaters, and there's no gray shirts.
Oh, okay. Yeah. So 23
Yeah,
over.
so now we can actually go, you can answer the question here. Yeah, we know the total is 23. Gray or is a shirt? So gray or is a shirt?
Now we do. So that's one. Would it be 23 over 11?
It'd be
No,
11 out of 23. Very good.
11.
Yep. And then let's see if we can get one more done here. Yeah, that's 0.48. Okay, let's make one more table. All right, so here's our table. So we have stars and rockets, rockets, small and big, 6 small stars, 8 big stars, 11 small rockets, 4 big rockets. Small or is a star, small or is a star. So there's small, there's star. We don't want to double count. So that's 25 out of 29. And that's 0.86.
And we're good. Thank you so much, Matthew. I
Yeah, of
appreciate
course.
it.
Of course. We'll go ahead and stop here for